Welcome to our Virginia Transformer Corporation plant, located in Chihuahua City in the Chihuahua State. Located about 380 kilometers south of the border between Mexico and the United States. Virginia Transformer Corporation was founded in the United States in 1971 with the object of supplying power transformers for underground mining in the nearby Appalachian Mountains. In 1995, Virginia Transformers began operations in Chihuahua, Mexico, having a rapid growth in sales thanks to the exceptional commitment with our service to customers and the application of engineering on designs that contributed to provide a good impression in the public, industrial, and commercial sectors. To talk about Virginia Transformer Corporation is synonymous of almost 40 years of experience in the design and manufacture of electrical equipment. Satisfied customers support our growth and the quality of our products. Our new and modern facilities in Chihuahua have 65,000 square feet in the main building, with engineered fluid layout along the large production areas. We also have a separate building assigned as the area of manufacture of metal implements, such as tanks, enclosures, and hardware. This building has an area of 16,000 square feet. At Virginia Transformers in Chihuahua, we are convinced that quality only can be achieved by quality people. So we have an induction program for our new staff, which is technically trained and developed into a culture of quality. In order to provide transformers with the appropriate quality and the particular characteristics that the client requests, we have developed a permanent training system in which the administrative, management, and operational staff of Virginia Transformers is always at the forefront of administration, operation, and process controls and the various tests executed to the equipment. At the Virginia Transformer plant in Chihuahua, we have the capacity to manufacture all type units from 300 kVA up to 10 MVA and 69 kV class, 350 kV BIL, with mineral oil, silicone, or FR3 EnviroTemp, as well as special oil suitable for very low temperatures. On dry type units, we have capacity of manufacturing units from 300 kVA to 5 MVA, and the insulation class of up to 35 kV with up to 150 kV BIL. On the following, we will proceed to make a brief tour of our facilities through our production areas, processes, and quality systems. Starting with the engineering areas composed by highly skilled engineers, all trained on the development areas within electrical and mechanical disciplines, having always the support of our expert advisory members of the IEEE engineers from the corporate VTC offices. Our plant counts on this department with the latest state-of-the-art technology in computers, thus maintaining a leading position on the engineering challenges that arise every day. Our greatest strength on the engineering department is to produce custom designs to meet the complex needs of our customers. Our designs fully comply with ANSI, IEC, NEMA, CSA, UL, ABS, and OM, and we are certified ISO 9001 version 2008 within this process. Also, the designs here are safer and faster thanks to the automated design software which we count with, named as BTM. We have well-organized warehouses, one that is designed for the wire and strip conductors that will be used in the coils. The second one is used for the storage of silicon steel used in the cores, and the third one where the rest of the accessories used in the process, such as gauges, monitors, bushings, and other attachments that make up the transformers, are stored and controlled. Our purchase process through certified suppliers, tracking and receipt of materials is done by our staff located in the same plant, giving us great advantages in terms of reaction times and monitoring. Likewise, the incoming inspection process is carried out by the quality department to all materials and certificates of quality, ensuring that they comply with all the standards before being admitted to the plant. Once the design has been released by engineering and approved by the customer and the material available on plant, manufacturing process begins with the area of low voltage winding. In this area, we use patented machinery, specially made for the construction of coils, with either electrical grade copper or aluminum. while placing the insulation between layers with Nomex paper rolls or glue craft paper. Rollers and pneumatic brakes allow to apply an appropriate tension to the windings to ensure optimum performance on the transformer. The winding machine operators are trained and certified to perform this process. The low voltage winding inspection process verifies that important parameters of the coil, such as the number of turns, perimeter, diameter, as well as welding terminals to the sheath, are within the ranges calculated by the engineering and design areas, using quality methodologies such as zero defects quality and effective inspection. The process continues with the high voltage windings. In this area, high voltage windings are constructed using electrical grade copper or aluminum, covered with Nomex paper coated for dry type units or with craft paper type for all units. The staff has the necessary training to follow exactly the instructions stated on the electrical design drawings and instructions. Once coil is wound, we continue to our encapsulating sealing processing area. Encapsulation procedures such as BPI, Unidip, end capping, and Uniclad are strictly controlled by PLCs in times and temperatures to ensure an excellent seal and long life of our windings. The BPI process consists on removing moisture from the materials at high vacuum and then proceeding to impregnate the coil with a special epoxy resin. It is proceeded to cure or solidify resin in ovens at high temperature. We can produce coils of different configurations such as barrel type, disc type, and helical. Inspection of the sealing process and impregnated coils verifies that important parameters such as pressure, vacuum, time, and temperature are always within specification, assuring the coil's quality and long productive life of transformers. Meanwhile, in the core cutting area, a precise German manufactured machine is used to cut silicon steel sheet in the most accurate and efficient way, by not allowing variations or burrs in the cut. The most common steels used here are the M3 and M6 with a meter type cut setting, and if necessary, we can bring from our sister plant's step lab core cut steel. The inspection in this process focuses on strict verification of the squaring of the pieces cut to 45 degrees, as well as the repeatability in the length of such parts. Then, these sheets are taken to the core stack area, where steel plates are overlapped with splices based on the type of cut, in order to generate the lowest excitation current possible, as well as to ensure the lowest core losses. The assembly area of core and coil, which is carefully done, mounting the coils on each leg of the core to ensure optimal support and restraint. Here, the placement of insulators on hardware and top core is also done. The inspection process in the core and coil assembly verifies the electrical clearance between coils is met, complying with the minimum required by engineering and design, since this minimum distance ensures the long life of the insulation of these coils. Also ensures that the coils are properly seated and secured through the metal hardware. While performing these processes, in the separate building for metal fabrication, they are produced in two different lines: oil tanks and dry type unit enclosures on which all previous work will be protected, assuring that the required voltage reach its destination. This area works in accordance to the mechanical design package, previously endorsed and approved by our engineering department, and has technology that leaves us as leaders of the market. Within the metal fab, we have cutting, bending, assembly, welding, and painting processes that can be performed manually or through robotics. For the oil tank line, first task is to make the necessary cuts to the plate. To have this done, high-tech machines are used, such as CNC plasma, in which accurate cuts through numerical control is made. Drawings from the engineering and design department are transferred directly to this machine. After this, they go through a bending stage with high capacity and accuracy CNC benders. Later, parts are welded to achieve our tank shape. Here, there is a robot equipped with a vision and laser guidance system that carries the torch route to avoid any damage in welding and ensure effective process. The rest of the manual welding is performed by highly qualified and certified personnel. At the inspection process for the tank manufacturing, it is verified that the tank meets all critical and important measures, inside and outside, set previously in mechanical drawings. Also, checks all welds used to put all the pieces together that make up the tank. It is important to mention that all of our welders are certified, as well as all the welding processes used to ensure that the tank supports electromechanical forces. After finishing the whole welding process, the staff makes an initial pressure test to the tank to check for air leaks. This is accomplished by injecting 10 psi of air for 12 hours to ensure there will be no oil or nitrogen leaks during the operation of the transformer. Once past this quality test, the tank is sent to our sandblast booth, where aluminum oxide is applied at high pressure to remove any impurities that might be deposited on the metal and create an appropriate anchor with a metal finish suitable for the base primer, which will be applied in following process. We have 3 paint systems applied according to our customer request. It is defined according to the area where the transformer will be used, so the System 2 is used when our product will be placed indoors. The System 3 is used when the product will be exposed to high humidity, non-aggressive outdoors. And finally, the 4th system is used when our product will be located in a high humidity environment with saline and highly corrosive elements that affect the paint life of the tanks. Each system has its requirement in paint film thickness. It is analyzed with a digital magnetic thickness gauge, proceeding to the final inspection by the quality department, and sending tank over the final oil assembly area to continue with final assembly process. In the final inspection of the tank, the adhesion of paint is checked, as well as color, thickness, and compliance with all requirements and details that show mechanical drawings are reviewed. On the other side, for dry type transformers line, the first task is to make the necessary cuts in the steel sheets. To have this, precise cutting machines are used, then passed to a CNC punch press that ensures the accuracy and quality of the holes required. After this, they go to a bending stage with high capacity and accuracy CNC benders. The pieces are sent to a minor welding stage for joints, which is made with highly qualified and certified personnel. After the welding, the panels move to a different stage in order to proceed the greasing, washing, phosphatizing, and chromic sealing, which ensures an excellent anchor for the painting. It is worth mentioning here that it is used a super durable powder paint system polyester type that is applied to the enclosures with an electrostatic system and then put in a curing oven at high temperature. In the final inspection of the closure, the addition of paint, the color, and the thickness are checked, as well as the compliance with all requirements and details that show mechanical drawings. Once the unit has been assembled entirely, they go to our electrical testing laboratory, where they are verified at 100% using modern, updated test equipment that is required to carry out routine testing, validation, and special testing on power transformers. All tests performed in our laboratory meet strict U.S. standards, ANSI, IEEE, CSA, and ISE standards. Our test engineers have been trained to implement all the required electrical tests, as well as to make appropriate interpretation to ensure a safe and effective operation of the transformer. Also, in our testing area, we use the test equipment and most advanced technological developments for the appropriate protection, control, and test application. To ensure that each element of the transformer meets the technical requirements and quality, it has a 3-stage protocol of tests as follows. To windings, ratio resistance and impedance, preliminary testing to the core and coil, ratio, winding resistance, no load losses, excitation current, and load losses. Final transformer test. Preliminary tests are repeated, and it is also performed the double induced test, as well as the applied voltage and accessories testing are performed. We are capable to perform special testing in order to meet the strict industry requirement standards such as impulse, hit run, and partial discharge tests. During the final inspection of the transformer, it is verified that the transformer complies with all the measurements at the 101 sheet drawing, also called customer sheet. verifies the installation of all the requirement accessories stated in that sheet, as well as proper operation. Also, it is carried out the calibration of temperature gauges. Finally, when the transformer has been identified, packaged, prepared, and protected for shipment, it is placed in a special boarding area, which has high-capacity cranes that allow proper placement of the transformers in the transportation, and thus ensure that the customer receives a high-quality product, according to your specifications, design, and advanced technology, manufactured with the finest materials available, tested under the most stringent international standards, and with the confidence that it will work without any problems for over 30 years.